Next topic is cyclotron. Cyclotron is a device which is used for accelerating positively charged particles like proton, neutron, alpha particles and heavy positive ions to desired high velocities. This was developed by Lawrence and Livingstone. Now the principle of cyclotron. The working of cyclotron is based on the fact that a positively charged particle can be accelerated to a sufficiently high energy with the help of smaller values of oscillating electric field by making the particle cross the same electric field time and again with the help of strong magnetic field. Construction of cyclotron. It consists of two D-shaped hollow evacuated metal chambers D1 and D2 called the Ds. These Ds are placed horizontally with their diametric edges parallel and slightly separated from one another. These Ds are connected to a high frequency oscillator. This high frequency oscillator can produce a potential difference of the order of 10 raised to power 4 volt at a frequency of 10 raised to power 7 Hz. The two Ds are enclosed in a steel box, evacuated steel box. Two Ds are enclosed in a evacuated steel box and these are well insulated from the steel box. This box is placed in a strong magnetic field produced by pole pieces N and S of strong electromagnets. The magnetic field is perpendicular to the plane of Ds. The ionic source or source of positively charged ions, this is held at center P as shown in this figure. Now the working and theory. Suppose at any instant D1 is at negative potential and D2 is at positive potential. Therefore, ion will be accelerated toward D1. On reaching inside D1, the ion will be in a field-free space because electric field inside a hollow conductor is 0. Therefore, the ion will move with a constant speed inside D1, say V. The ion will move with a constant speed inside D1, say V. But due to perpendicular magnetic field, the ion will describe a circular path of radius r, which can be calculated by the formula BQV is equal to mv square upon r. BQV is the force due to magnetic field on the moving ion, and mv square upon r is the centripetal force. This force on the positively charged ion due to magnetic field, this provides the necessary centripetal force. Here m is the mass of the ion, q is the charge on the ion. From this we can calculate r is equal to mv upon bq. Therefore, time taken by the ion to describe semicircular path, time taken by the ion to describe this semicircular path. This semicircular path is time is equal to distance upon velocity. Distance is equal to circumference of a semicircle, which is pi r upon v. Putting the value of r from here, it is pi in place of r, we put mv upon bq and divided by v. We get pi m upon bq, which is a constant. Therefore, this time to describe semicircular path by the ion is independent of both speed of the ion and radius of circular path. In case the time during which positive ion describes the semicircular path is equal to time during which half cycle of the electric oscillator is completed, then as the ion arrives in the gap between two Ds, the polarity of Ds is reversed. That is, D2 become negative and D1 become positive. Therefore, ion will be accelerated toward D2. Therefore, it enters inside D2 with a greater speed. This speed remains constant inside D2. But due to perpendicular magnetic field, the ion inside D2 will describe a circular path of greater radius and again arrives in the gap between two Ds when the polarity of the Ds is reversed. That is, D1 become negatively charged and D2 become positively charged. Therefore, Every time when the ion arrives in the gap between two Ds, polarity is reversed and ion is accelerated every time when it arrives in the gap between two Ds, and it describes the circular paths of greater and greater radius with greater and greater speed, and finally it acquires sufficiently high speed. This accelerated ion can be removed out of Ds from the window W by applying electric field across the deflecting plates E and F, and thus we get positively charged ion with sufficiently high energy. Now the maximum energy of the positive ion. Now we will calculate maximum energy of the positive ion. Let V naught is the maximum velocity acquired by the ion and R naught is the maximum radius of the circular path followed by the positive ion in the cyclotron. Then mv naught square upon R naught is equal to bq V naught. From this we get V naught is equal to, from this we get V naught is equal to bq R naught upon m. Therefore maximum kinetic energy will be half mv naught square, half m into, in place of V naught we put this, therefore we get b square q square R naught square upon 2m. Next is the cyclotron frequency. If t is the time period of oscillating electric field, then t is equal to 2t. Small t is the time taken by the ion to describe a semicircular path, as small t is pi m upon bq, therefore t is equal to 2t is equal to 2 pi m upon bq. Therefore cyclotron frequency is the reciprocal of time period. Putting the value of t, we get nu is equal to bq upon 2 pi m. This is known as cyclotron frequency, and this is also called magnetic resonance frequency. The cyclotron angular frequency will be omega c is equal to 2 pi nu. Put the value of nu from here, we get omega c is equal to bq upon m.